ओके ओके गाइस, तो लास्ट क्लास में हमने सेशन 2 का रिवीजन कर लिया था सारा, है ना। अब सेशन 3 का रिवीजन करेंगे और इस बारी मैंने कोई लेके नहीं आया हूँ उस चीजों को, है ना। इस बारी क्या करूंगा मैं, एक 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 स्क्रीनशॉट उठाता रहूंगा और एक्सप्लेन करते रहेंगे, पर सारा रिवीजन करते रहेंगे, बेस्ट रहेगा ना। ठीक है, चलो, तो स्टार्ट करते हैं गाइस। तो इसमें कुछ नहीं है इस वाले सेशन में, ठीक है। जो कि हम टॉपिक कवर्ड कर चुके हैं वो अलग है, जैसे सीपीयू रजिस्टर्स, जैसे कि हम सीपीयू रजिस्टर पढ़ चुके हैं, ठीक है। जैसे हम क्या क्या पढ़ चुके हैं, दिस इज द वे टू टीच, राइट। ओके, ठीक है, तो अपन पढ़ क्या चुके हैं, एक तो रजिस्टर्स पढ़ चुके हैं, या फिर हम इसको फुल स्क्रीन कर लेता हूँ, कोई दिक्कत होने। अच्छा, ये नया मेरे को एक ऐड करूंगा, ये हमने पढ़ चुके हैं, ओ सॉरी। ओके, लेट मी ओपन, ठीक है। एक बार ओपन कर लेते हैं, बाय मिस्टेक क्लोज्ड। yes, in the cow revision we have add the pages. Today's date is 18 slash and 11, right? And session is nothing but session is अभी सेशन 3 को टारगेट करेंगे, 3 और 4 को, 3 एंड कॉमा सेशन 4। ये today we will cover these two session revisions, ठीक है। Okay, let's go start view and go to the full screen. Okay, we have full screen maybe not possible because I need to take a screenshot from there to there. Okay, so here, so I'm just taking the screenshot. So these are classes we covered. Which classes? The CPU registered we covered. Okay, we covered. Okay, so now we covered the CPU registers, right? We covered CPU register. Okay, we covered CPU register, correct. And type of the architecture. We have a five type of architecture that we have covered. And program counter we covered. Instruction registers we covered. Okay. And stack pointer also we covered. These are the recap topic. Okay, we covered. So now next is we have covered also CPU registers, which is we covered also CPU registers. Okay, CPU registers we covered. Okay, we covered these many things also. CPU registers, memory addressing, memory access, and architecture based base size input. Okay, so now today we are talking about like just we are recapping that that address registers, address registers. So address registers is this. Give me a minute, guys. I need to import that. Okay. So we are not wasting our time. Correct. Save. So the download section I need to save. Okay. Okay. I need to be here to insert the file attached. We would call insert attached file insert file. Okay, this is third not working. This not happening. Okay, I need to insert the file printout. Let's see. Okay, थैंक यू कुछ गोली मारते हैं ये अपन नहीं करना है आज तो अभी हम भी करते हैं इसको पूरा ठीक है ओके यहाँ से स्टार्ट करते हैं रिकैप वाला छोड़ते हैं so let's start from here okay view in the full screen okay so now we start addressing registers or like EMAR MAR registers used to send address to the memory. This register used to send the register. Last class we have seen. Okay, last revision session we have seen these things, guys. These things we have seen last class. Okay, so now data registers. Data register also we have seen that registers like MDR, MDR registers, AR registers. ठीक है these are used to that uh, address registers is send address to the memory. Address registers is nothing but send address to the memory, right? This is the memory and this is the address. Suppose that address it is sending using the registers address. Data registers is used to send the data to the memory, which is and receive the data from the memory. Which register used? This register we used, like giving the data and taking the data from that memory. This is the memory. Correct, guys? So now this is the simple things we have seen. So now coming to the memory access point. So memory access point we have that like CPU, okay, and the CPU, correct. The CPU AR and DR. These are the registers. We have a two type of registers. Okay, address registers and memory. Like last one is the data register. Like this one is this one is address register and data registers. So address registers in the CPU, the CPU inside the CPU, address registers is available. Okay, address registers is doing sending the address to the memory, sending the address to the memory. But data register is doing like sending the data to the memory and taking the data to the from the memory. Why? Because it is the bidirectional, right? And here we have a read, write, wait, ready. These are the steps. In meanwhile, we can see like read, write, wait, ready. Okay. Some data is transferring. Maybe is reading the data, like writing the data inside the memory, right? The things we are performing, reading the data inside the memory, writing the data inside the memory is happening. Okay, and that like wait the CPU. CPU will wait. Like if you try to read the data, but CPU in the memory is busy, then it will send a signal to the wait. Okay, when it's ready, then it sends a signal to the ready to the CPU. You can read the data, or like you can write the data, or like sending the address kind of thing. So this is the memory access point. So now I'm just doing something. The this is the CPU. Okay, this is the CPU. This is the AR address register. This is the DR. Okay, this is the memory. Okay, AR is sending the data, sending the address. AR is sending address, sending address, correct. And data register is sending the data and reading the data from the memory. Data registers, right? And meanwhile performing these operations, we have to four things. Once we read the data from the memory, right, and write the data from the memory, write in that the data in the memory, and that is memory give the response to that CPU. If it is waiting, then it's okay. If it is not waiting, then it's give the ready to the ready signal. If it is ready, you can read, write whatever or action is required. You can perform. This is nothing but called that memory access. Memory access. Memory access. What is that meaning? Memory access. This is the memory access point. Memory access. How the memory access CPU. CPU the memory access. ठीक है? Now next is coming to that memory read. Here we have so right written a point. Let's try to understand this point also. Okay. The first point is CPU send address to the memory through the address bus. Okay. This is nothing but a address bus. What is that? This one. This one is the in the starting revision session we learned that what is that we learned about the buses. So these are the buses, right? So memory read means what is the function of the read? I have told you, I have told you guys, we are reading the data from the memory, correct? We are reading the data from the memory and writing the data inside the memory, right? So what is the meaning? CPU send address to the memory through the address bus, correct? Read operation. These are the read operations. CPU send the enable read control signal to the memory. Okay. CPU sends enabled, which is sending to enable the read operation. CPU will sends. Correct. And memory read on give. Memory reads. Memory reads given address and the content is sent to CPU through the data bus. Right. Correct point. What is that meaning? Memory reads on given address and content is sent to the CPU through the data bus. This is the only reading the data which is sending from that CPU, right? And memory wait. What is that memory wait? Wait. So CPU sends the address to the memory through the data bus. ठीक है. CPU is sending the data to the memory through the memory bus. Okay. Okay. Now second point is data bus. Now CPU sends data. First is sending the address to the through the data bus and the data through the data bus. Correct. Address भी data bus के through भेजा ये भी. But CPU sends enabled wait controlled signal. This one the same. Memory performs wait of given data on given address. It will perform the wait operation in the data given data. Okay. Now, next are the memory addressing. Last we learned about the memory access point, memory accessing. So how memory access? We can access the memory through the address registers and data registers. Data is reading the data, writing the data. Okay, both operation we can perform bi-directional using the buses. Okay, and now next is the memory addressing. Okay, memory addressing is here we can say in the memory, we have the memory and 1 2 3 4. This is that address. This is the memory address 1 2 3. Here we written as a memory. Here we written as 1 2 3 why? Because the our understanding. But inside the memory is 0 1 0 1 kind of thing is written like that 0 1. If it is 4 byte, if it is 4 cells in the memory, and each cells contain 1 byte, okay, 1 bit. So then it is that, right? 1 0 1 4 2 kind of thing is okay. Addressing of memory, address of the memory. These are the address of the memory. Memory address, memory address. This is the 8 cell. This is the particular cell inside the memory, and each cell having some address. Okay, each cell having some address. 4 cell address size is 2 byte. Suppose address size is 2 byte. This is the starting with 0. It is 2. It is 4. It is 6. Correct. Like what is that? 0 0 0 1. Okay. 0. So let me do something. 0 0 0 0 1 2 4 6. Correct. Suppose we have a 1 and 1 for 2 byte. 3. 1 0 and 0 is means 0. 0 1 means it's 1, and 1 0 is means 0 1. That's a 2. If it is 1 is 1 is 1 is 3. Okay. Address size is 2 bit. Here we have address size is 2 bit, but here we address size is 3 bit. Like here address size is 2 bit. Like 2 bit we have in 0 0 0 1. These are the 1 bit, and this is the 1 bit. Okay, got the point. Okay. So now next is, this is the memory addressing. Next memory addressing related things are there. Suppose number of cells, we have number of cells. We have number of cells 4. Then address size in bit. Address size in bit. Address size in bit. Number of cells. In the above, we can say number of the cells. Number of the cells is 4. Okay. Number of the cells is 4. 4 cells. Number of the cells is 4. Then address size in bit. Address size in bit. Suppose we have a 4 cell, 1, 2, 3. Then they are trying to ask what is the size of one cell. One address size, 1 bit. Size, address size in bit. In bit. The 4 is rising as 2 power 2. Means 2 is the bit, 2 bit. Correct. Suppose we have a 8, then 8 is 2 power 3 means 3 bit address, like 0 0 0 0 0 0 1 kind of thing it will come. Now next is 16. 16 is 2 power 4. Then 2 power 4 is 4 bit. Then it will like that 4 bit. 32 bit 2 power 6. 16, 16 दूनी बत्ती 2 power 5 is 32 bit. 32 bit. 32 bit, 32 bit address. Like that. 5, sorry, 5 bit address. 0 0 0 0 0 like that. Become 5 bit address. Correct. So now suppose they are asking number of cells we have 2 power x something. Then what is that address size in bit? Address size in bit. Address size बताना है इसका. Now we need to find out the address size bit. How many bits address is stored in one cell? So now we have given 2 power x, and now x bit is address size of the cell. Address size in bit. Now If it is n, then log 2n bits, then bit will become 2 power x, 2 power x. Okay. So some question we have solved. Number of the cells in the memory is 2 power. Number of the cells is number of the cells how many? 2 power 256. Number of the cells 2 power 6. Then address size is now we can write this as 2 power 8, correct? Then 2 power 8 address in bit is 2 power 8. How we can take it? Here you can take a log 2 base 2 power 8 become 8. This value become 1 and 8 will become 8. 8 is the answer. This is the answer. Correct. Now number of the cells is 64 MB. 64 MB. Number of the cells is 64 MB. Number of the cells is 64 MB. Okay. Now address size is find done address size. Number of the cells 64 MB. 64 MB means 32.5 2 power 6 is 64 MB. Now MB become a KB, then we multiply 10 2 power 10. Then then 2 power 6 multiply 2 power 10 bit. Total is 2 power 16 bit. Taking the log 2 base 2 power 16 at the size is 16 bit. Okay, 20 not a 10. It's MB not a KB. It's bit is KB. Okay. Somehow I'm forgetting. It's MB converted into the byte. So we need 2 power 20. Okay. 2 power 20 we need. So now this question is solved. Second question is number of the cells is 16k. Number of the cells is 16k. Address size बताना है. Address size is question mark. So now 2 power 4 multiply it convert k into bits में चाहिए k into bits 10 to power 10 to power 10 to power 10 10 to power 10 now 2 raised to power 14. Okay, then 14 is that. 14 is the answer now, right? Okay, the memory which address is 12 bit. 12 bit, correct? Number of the cells you need. Okay, 12 bit, 12 bit, 12 bit, 12 bit. It's 12 bit. So it's a 12 bit. Listen here, this is not number of the memory. It's giving the number, the memory with the address is 12 bit. It's giving the address of 12 bit. Now find the cell. Cell is question mark. So we need to find cell. What should we do? Previously, we are doing like just powering the two. For that, given this is 2 power 12. Is 2 power 12 is nothing. If you want to k, if you inside the k you want 2 power 12, 2 power 12, then 2 into 2 power 10. The 2 power 10 is k, 2 power 4 k is the answer. 4. Now we understand if you know the number of the cells, if you know the number of the cells, okay, if you know the number of cells, then you can find the address as well. Okay, if you know the cells address size, you can find. If you know the address size, then you can find that what is that number of the cells. How many number of the cells is stored in that particular address? काय? Kavi. Almondazol kavi. अरे, पढ़ लेना है. हाँ 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 डरी है. 31 पावर हो. क्यों निकल? हम तो खाई नहीं थे तुम्हारे जितने ही थे मुझे क्या पता. तो तीनों नहीं निकाले मिले जो भी खाओ. जो जो ना भाई अभी बाकी है. हाथी पाँव. तो हाथी पाँव होगा ना तो. जा बोली. क्या कोई खाया था बच्चा है आधी देश में. उल्टी हो जाती है. काय कर. टट्टी. जाते. हाँ. बच्चे कर खाया मीठी है. तो तुम्हारे तो क्या बोले स्कूल में बाबू जल्दी. मैं चीज ना. मैं खाली सच्ची पी दे. तो याद है तो जरूरी दो ना कीड़ा हो दो कीड़ा. कैसे. मतलब राइट. तो होता है. पूरा मतलब. पढ़ ले. हाँ और मम्मी क्या है. मम्मी क्या है बोलने का भी. Sorry for the disturbance. Okay, so now let's start. Next question. If you know that type of memory, okay. So now type of the memory, types of memory. First, we know the how to access the memory, right? First, we learn how to access the memory, okay, and memory addressing, how the memory addressed. Now, next topic is we are going to learn the memory types. Okay, memory types. We have two types of memory. This is the important. Every like in this chapter, that question is come from the byte addressable and word addressable memory. So now byte addressable means each cell memory one byte is stores, right? Byte addressable. Each cell memory one word is stored. One byte and one word, right? These are the cells. We know that word addressable, byte addressable. One bit inside the cell is storing only one byte, right? One byte, one byte. Not more than that. Here is one word is stored. It is fixed. We cannot change. Okay. Now come into the question parts. Byte addressable memory. Here we can say the byte addressable memory is there. So number of the cells is 16. Number of the cells is 16 and memory type is byte addressable. Then 16 and each cell is storing one byte, correct? And 16 cell, how many memory is storing? 16. 16. देखो, total memory capacity is 16 byte multiply 1 byte is to 16 byte. 16 byte means address size. If you know, if you want to, if you know the size, it's know the memory. Okay, memory byte. How many bytes? 16 byte. You can send the address as well. How many bits address? Will store like 4 bit, like 0000. Like size is this total memory, right? So we know that. Okay, we know that We know that total capacity is 16. Total capacity is 16. Okay. Each cell is storing one. If you given cell is storing each cell is storing two, then if you get something new value. But here is storing only one. So we will get 16 itself. Okay. 16 itself we get 16 byte we get. Okay. So now address size if you want. Fine. Address size equals to log 2 16. Then we come here you go. Not able to see. Okay, I need to up the page. Okay, now you are able to see. Okay, then address size is this. Then here log 16 base to 2 power 4. 4. Then will become 4 bit. 4 bit. So now the address bit is 4 bit. 4 bit address is storing for each cell. Each cell is storing 4 bit address, correct? Now this is the question. Now next question is if uh if byte addressable memory has 32k byte capacity. Now the capacity is given capacity total capacity is 32 byte. Okay, 32. The number of cell in memory, the number of cell, the total is 32 bit. This is the total. Okay, total is 32 bit byte, right? Each is storing one byte. Okay, so now 32 multiply 1 byte equals to equals to equals to 32 byte. Okay, now number of the cells, if you want, first you need to address as well. Address for this address of the cell, कितने bit का address you are storing. So we need log 232, then log base 2 की power 2 is 6. Now the 5, it's 5. Then it's become 5 bit. So now every is storing 5 bit. Then if you know the address, then if you want to find the cell of what is that is asking about, the address size of memory and cell of okay. या, मैंने वैसे वाला तरीका निकाला ना, ये देखो सर ने बताया 32 बाइट, ये फॉर्मूला सा है एक। 32 kb byte equals to number of cells and multiply 1 byte. Okay, 1 byte. Number of the cells, number of the cells, now bit में चाहिए ना, bit is 10 तो 10 to power 12, yes. So the size is 15. So now this is not work out. A lot of way we can do. This is my understanding which I have applied, but this is not work out. Just unfollow the circle construction. So one formula we have, like we need one formula. Capacity byte capacity 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 equals to number of cell multiply 1 bit. Okay, the capacity is given 32k equals to number of cell equals to 1 byte. The number of cells equals to number of cell cell equals to 32k. Then this I want to convert into bytes. Okay, because answer is in the byte. 32k is good. Memory cell number of the memory cell is 32k. K is good, but I need to convert into the bit. So what is that formula? 2 power 5k. Now k is converting into like 2 power 5 multiply 2 power 10. It's become 2 power of 15 bit. So now number of the cells is 2 power 15. So then 2 power 15 is that number of the cells. Then address is 15 bit. 15 bit address you can store. So this is the question, the approach. Okay, so now next is maybe मेरे स्क्रीन के पीछे यार छुप रहा होगा. Okay, please adjust. क्वेश्चन फ्रंट पे ये मेरी प्रैक्टिस है. दिस इज फॉर माय प्रैक्टिस पर्पस. Okay, now next question is that next question is what is that? Next question is consider a next question is consider a byte addressable memory of size is 4 GB. 4 GB. Address size of memory. Address size of 4 GB addressable memory of size. The consider byte addressable memory size. The total capacity दी गई हुई है इसकी 4 GB. Correct. 4 GB equals to the address size number of cell equals to 1 byte. Okay, now here you can see the number of the cells if you want, the number of address size, number of the cells if you want, then equals to 4 GB equals to 1B. 1B is cancelled, GB is cancelled. 4 into 4 into G. G is nothing but GB. So 1 become 4 into 2 power 30 bit. That it's become 2 power 32 bit. 32. This is the address. What is that address is 32 bit. Address will become 32 bit. Here is same. Here is also same as the number of the cells. The size bit. The consider a byte addressable memory of size 4 GB and address size of a memory is 4G, we said we cancel करके ना, 4G is converting to the 32, 32 is addressable. Okay. Now next question is the memory size is 256 byte, 256 byte, byte, correct. And word addressable memory is one word of 4 byte, means total size having 256 and each word is 4 byte. Right, number of cell in memory पता करनी है, then address size पता करना है. Number of cells निकालनी है, number of cell and address. Then you can find the number of cells, then address you will find automatically. So that we have a total size means 256 byte. We have equals to cell. We need number of the cells into one word we have. Okay, one words is having 4 byte. What is that? 4 byte. We are storing 4 byte. Correct. If you want the number of the cells, the number of cell equals to 2 power 6 byte upon 4 byte. B said B cancel. Then let's become bit. Few 2 power 64, I think to 8 it become, or like 6 it will become. Let me draw. 64, and it's 64 become as 2 power 6, then 6 is bit address, and cell is 2 power 6. Cell is 2 power 6. Here, cell is number of the cell is 2 power 6. 2 power 6 means 64, and so 2 power 6 is 64. Okay, and at the size is 6 bit. Correct. Why? Because in the address is total size is given. If you given the total size, then the formula is will become the number of the cells equals to number of the total capacity, or like total byte is equals to number of cells multiply byte, one words, or like one cell is storing, that you can store here. Now next question is next question, word addressable memory of size 2 GB. Word is 8 byte. Word size is 8. Every word is 8 byte. Right? 8 byte. Then find the address in bit. 2 GB. The addressable memory of size. Total size is 2 GB. Then 2 GB. Correct. Equals to number of cell multiply. What is that? One bird size is 8 byte. 8 byte. Correct. The number of cells equals to, then it become 2 power GB equals to 8 B. It's divided. It's 2 power into 2 power G matlab 30. It's become 2 power 3. Okay, then 2 power 3 is cancelling. 2 power 3 is cancelling means 2 power 3 is when we have divide, when we having inside the denominator, then power will be the minus. Okay. 2 power 3 is 27. And 7 is 28. 2 power 28. Correct. 2 power 28. Then the 28 is the bit address. The address is 28 bit address. Is storing 20 bit address is storing inside the every cell. Like something. 28. You can just find the log formula. So you can use it. Not a big deal. Same thing I have done here. Same thing I have done. Just I divided to this. I'm just subtracting 2 power 30 from 2 power 30 to the 2 power 30 minus 2 power 3. Then it's become 2 power 27, but 1 is added to 2 power 8. That's why it's 2 power 28. Now next is architecture based. Now we have some question based on the architecture based, correct? Architecture based, architecture type based size. Like we have 32-bit input, 32-bit operand, 32-bit input, 32-bit operands. Then LU result in store into the accumulator, 32-bit architecture. CPU words, 32-bit means 4 byte. 32-bit means होता है 4 byte, correct? And 64 means 8 byte. 2 power, 2 power, what is that? How we can say 2 power 4 is 16, 2 power 5 is 32, 2 power 6 is 64. Then why it's written bit, it's byte, 8 byte, 8 byte converting into the bit. Then 2 power, it's 6, should be 6, not 8. Now we have learned CPU registers कौन कौन से यूज होते हैं. AR or data register. This is that for sending the address to the memory, and this is sending the data to the memory and reading the data from the memory and addressing memory. It is storing the memory inside the address like 00. This is the memory addressing, and we have some question. We solved some question on based on the memory addressing and memory access, how to access the memory, like read, write, and all these things, architecture based. So that's it, finished. So now let's delete this one. Okay. Okay. So now I want to just, okay. Let me, if anything possible, page table translator not possible. It's pictures. Okay. Okay. Okay, so now I'm just inserting one more. Okay, one more session PPT, session 4 PPT. Okay, there we have lots of questions. Okay, give me a moment, guys. Give me a moment. Give me a moment. Now, it's visible. I have imported my next slide to the next session, session 4. So now in this session, the last जो हमने PPT पढ़ी है उसमें हमने we absorbed lot of questions about the memory and how to access the memory. In this session, we will learn more about it. So let's recap this. So we have know the CPU register, what is that memory addressing, we know how to access the memory, we know that architecture, we know that input, micro operation and memory access. In this slide, we will cover. Now, first we need to solve some questions. After that, we are going to let me frame. Okay, so consider a memory which size is 64 byte. The address size is access. If memory word is addressable is 1 is 2 byte. Memory size is 64 bit. 64 64 KB kilobyte, right? Equals to cell number of cells multiply each, it's a word addressable, one word is 2 byte, correct? Then number of cell equals to 64 KB divided by 2V, right? KBB 4 is 32. 32 is nothing but 2 power 4 5 or and k is nothing but a byte, you need to convert it as kilo. So kilo is 2 power 5 multiplied need to bit multiplied 2 power 10, then 2 power 10 has become 15, then 15 bit, then 15 bit, then 15 bit is nothing but this 15 is byte addressable. If you know that address is 15 bit, correct? 15 bit address we get it. We use this. Okay, now next question. This equation we have now learn the concept. What is that? How instruction is stored in memory? How instruction is stored in the memory? Inside the memory, we need to store the instruction. The memory type addressable होना चाहिए. Instruction size is 1 byte, right? So 1 byte is storing instruction 2 1 3 4, like 0 1 or 2 3 4, like dot. We know that this is storing the program instruction. Suppose here examples 2, here we can memory byte addressable is there, right? It is storing the byte addressable, not byte addressable. Instruction size is 2 byte. Now the each instruction is 2 byte. So inside the memory, in the previous session, we know that inside the one cell you can store only 1 byte, right? We cannot store 2 byte, but here we have a instruction size is 2. So now what we have to do here, we need to do here inside the instruction I1 is storing inside the two places 0 0 0 1, right? Like that. Like that same here you can see instruction 2 is 2 byte is storing from 2022. 203 is also storing here, also it start from 204. Here is it starts from 206. Here is it start from something. Now 298 up to 298. How you know that the total memory is storing? How you know that total? So it's 2 byte, 2 raised to 2 the initial. As 2 is initial, sorry, 2 is initial, right? 2 is the initial 200, but is up to go to the 98. Someone trying to ask how many instruction we can store inside the memory total if total uh, what is that byte address for instruction size is 2 byte and bit is something we know that. Okay, let's go with another example. Now here we can see that instruction size is 4 byte. Correct. The memory word addressable is that not a byte addressable is its word addressable is 2 byte. Simple. It's instruction 1 and the storing from the 0 to 2 like that. Same thing is same, nothing special. If I4, if you want trying to store, then it is storing 2 power 5 is gone to 6. If you storing I5, then 2 powers 8. 2, sorry, not power 8. 208. Start from 208. Okay? It just starts from 208. Okay. Default memory is byte addressable. If you not given in the question, if question is not giving, this is the memory is byte addressable or like byte addressable. Default is byte addressable. This is the default is byte addressable memory. So now let's start some question trying to understand the CPU 4 byte instruction. CPU's 4 byte instruction. A program instruction I22, I1 to I200 start at address 200 in the decimal. Find the addressing following instruction. Find the addressing for I1 pick cache to row address I0 pick cache to. Let's see how to find it out. So if you know the okay, CPU has 4 byte instructions. CPU have 4 byte. Every instruction having 4 byte. 4 byte. A program instruction I1 to I200 and start from 200. It is starting from 200. To find the address, the following instruction. Okay, you know that starting point. The I1 is starting from here itself. Here you can say I1, you can know that 200 is good. But if you, how you can know that I5? If you go here you can see 200 and 4 byte. It is taking the 4 byte 0, 1, 0, 1, 1, 2, 3. 4 byte it is storing. It starts from 4, 0, 4, I2 and 0, 4, 5, 6, 7 and it just start from 08 I3 correct and 0 sorry, 12. Correct. I4 and I5 is 13. Sorry, not the 13, it's 16. So here 16, 216. 216 is 216. The I5 is instruction, I5 is address, the find the address of the formation. The address of 256. Address of I5 instruction is 216. Now I20. Now I want to calculate two. What that instruction is? Instruction is I120. Now here we can see that 5 and this is the formula. This is the formula starting. This is the starting of the memory and which you want instruction and -1 multiply the byte, right? So if you here can see, if you here you can see the 200, okay, plus multiply which instruction, 120 instruction -1 and multiply by 4. So 200 plus 100 minus is 120, 119 multiply 4 and 200 plus कुछ 36 नौ चार 36 की 6 4 4 एकन 4 और 3 7 4 एकन 4 46 676 I5 with 676. Correct. So what is the formula? Here we can see that one thing. Here you can say I5 starting from 0. I5 is 4 is 12, 3 is 8, 2 is 2. Something can remember this. So you can remember this, correct? Now next question. Next question. The CPU has instruction 4 byte. A program instruction I220 start at 500 decimal. What should be the PC value when instruction I6 will be executing in CPU? While I6 in the execution, then I7 the address will be in PC. PC is nothing but a program counter. Program counter is storing the next instruction of the execution. If you executing I6, it will storing the address of I7. So now I6 is execution, then I7 address will be in the PC. So address instruction I7 is this 500. So CPU has 4 byte instruction. If program instruction I to 200, the start at address 500 is, and what should be the PC value when it's asking not address the particular instruction, it is asking the PC value. So PC value should be the I7, not I6. So PC value is PC is storing the address of the next instruction. So you know find the address of that instruction. Okay, so everything the 4 byte is instruction. This is the memory. Okay, this is the instruction. Correct. The instruction is I1, I1, I2, I3. Correct. And here is 500. The starting is 500. Every instruction is 4 byte, then it's become 504, then it's start from 408 and 512, which is starting. So now like that, this is starting, correct? The address instruction, then address instruction I7 is I7 I7 instruction निकालनी है तो the 500, okay, and plus, okay, seventh instruction चाहिए 5 minus 1 multiply 4, 4 is the instruction, and this then 500 plus 7 minus 6, 6 multiply 4 is 24, 524 is the basic concept we revised. Here we know the PC. PC is storing that program counter is storing the next address. We are here here you cannot find the address of the I6. You need the find the you should find the value the PC is storing. PC is storing address. Okay, that's why some tricks they are trying to do, but it's storing the PC program counter is storing address of the next instruction. The little the things is there. Okay. So now next question is come here. Next question is the CPU has 4 byte instruction. CPU have a 4 byte instruction, correct? A program instruction here to here it start at address 500. What should be the PC value when instruction I will be executing in CPU? We don't know that exact figure. So 4 byte instruction is start from 500 plus and which you want I minus 1 multiply 4, correct? The 500 plus 4 I minus 1, like that 500 plus 4 I minus 1, then it's become we can minus 4 499. Okay, now the program counter I plus 1 we can find, na? It's plus 1. We forget it up. Nahi point बोलना, it's too deep. So I 500 plus and I plus 1 minus 1 and multiply by 4. Correct, minus minus cancel 500 plus 4I. Got it? This is the question. The instruction program counter I0 to I1 to I100. But we are finding that program counter value is storing the I. I is 0. I is program counter is storing the next value. Na? Okay. Now next question is address of variables. Address of variables. Address of the variables. मतलब previously we are storing the fixed variable inside the memory like 4 byte, 2 byte, 3 byte. But right now we are storing 1 byte. What is that? Like variable. Some where we store 2 byte, Somewhere we store 3 bytes, somewhere we store 4 byte. Like that we are storing. So that concept I am going to learn. Okay, so address of the variable size instruction. The variable size instruction is this, correct. So एग्जाम्पल के लिए ये है बाइट एड्रेसफुल मेमोरी लिए हमने, ठीक है, we take it byte addressful memory. Size is somewhere we in the instruction first is size is 2, instructions 2 is size is 3 byte, instruction 3 is 1 byte, 4 byte, like that. It's a different. So now how we can store this? The instruction one, the in the question they are given the instruction and instruction size. Okay, the I2 is I1 is storing 2, then I2 is starting from the 2, right, and storing 3 byte, 3, 2, 1, 3, 2, 3, 4, 2, 3, 4, just storing and start from the 5, like that, correct. Hmm, small questions, no, it's too big, too lengthy question. But small concepts. Okay, micro operation क्या होता है? Micro operation is the smallest operation CPU can perform at a time. Like one big operation, the divided into the piece of the operation is called that micro operation. It's called the micro operation. Micro operation. The operation executed on the value stored in the register. Which value is stored in the registers? The micro operation will perform. Okay, the symbolic notation describe the micro operation. This symbolic is more about we can learn in the question. Okay, so now here the micro operation like register transfer R1 to R2. Okay, R1 to R2 is transferring, comma R1 to R2 and RPC plus 1 stored into the PC program counter. Like both can be done in parallel, comma. If your instruction is this is a micro operation, important chapter. The question will come inside this topic definitely. One question will come. Okay. So here we can trans register means they are register transfer like that. If we have a some symbol like R1 like that R2 means R1 is transferring to the R2, transferring to the R2. Here if you have a comma separated, if you have a two function with the comma separated, these are performed that parallelly. Okay, memory transfer we have memory transfer, memory read. Okay, we have two type of memory. This is the data registers. Here M is inside the address means is the address, data register memory and data register memory AR is the address registers, data registers and the registers. Memory to registers. Here we perform memory to register. Here we perform memory to register. Here we perform what is that? Memory to registers. मेमोरी टू रजिस्टर परफॉर्म करने के लिए we have one dr data register. Inside the data register we are storing the memory. We have memory like that. This is the address. If you have inside the m it's some values there, you can solve the memory like memory weight m. If you having simple m and address like data register means memory weight. Example, R1 M100, R1 is 10. Okay, then R1 is 10, AR is 101, then AR is transferring to R2, R2 will become 5. Ah, okay, now coming to the question. Slowly पढ़ेंगे हाँ. पहले समझना, इट्स अंडरस्टैंडिंग इज इम्पोर्टेंट. ओके, मुझे खुद नहीं आते हैं. आई डोंट नो हाउ टू सॉल्व इट, but I will see and understand and then I will solve it. Definitely. Okay. Then consider the following program segmentation. Unnecessary things not required. Here R1, R2 are the general purpose register. What is that? R1 and R2 is the assume that the content of the memory location. This is 37 and all number are decimal. After the execution of this program, the value of a memory location is 200, 2000 is. Then आपको बताना है कि इस प्रोग्राम को एग्जीक्यूशन करने के बाद इस मेमोरी लोकेशन पे तो क्या वैल्यू होगी, व्हाट इज द वैल्यू ऑफ दिस मेमोरी लोकेशन. सो वी हैव अ इंस्ट्रक्शन एंड ऑपरेशन. Here we are 12 is transferring to the registers. In the first we can see 12 we can register to move to the R1 move, and here inside the 2000 register whatever is there is 37 is there and register to the R2. R1 is having, here you can see R1 is R1 is 12 initially, then R2 is become 37. The next instruction with R1 minus R2, then store into the R2, R2 minus R1, R2 37, 37 is 5, 2, 25, 25, right? The next instruction is move. R2 move to this register. R2 move to this memory location. 2000, some memory location is there. 2000, right? Inside the memory location for the 37 is there. Okay, then you process 27 is 25 is there, correct? And R2 move to that location, that's it, correct? Then stop. This is the moving function is having move, subtract R2. Now next question. Let's see. The consider the following program segment. Here R1 and R2 are the general purpose register. Assume that the content of the memory location is this. Then all number of decimal after the execution this program, the value of the 300 is. So then the previously we have 3000 memory address. Inside the memory 13 is there. Then R1 is assigning to first instruction is assigning E7. Then inside the 3000 R2 is there. Inside the 3000 R2 general purpose register is whatever inside the memory location is stored inside the R2 register. is 13 is stored. Then R1, then add 2, R2 and R1, R2 plus R1. R2 plus R1 is stored into the R2. It's become 20, right? Then R1 plus R2. R1 plus R2 is stored inside the R1. Then is 27. Then 27. Then 27. Then move R1 is moved to here. It's 27, 27. Then stop. What is the output of 27? 27 answer. Correct. Now here, note. Conditions are checked of just previous instruction result. Condition are checked to the previous result. जो previous result होगा ना उसके बेस पे condition check होगा. Correct. Okay. So next question is yeah. Okay. Instruction is we given. R1, R2 is general purpose register. Assume the content of the memory is 1000 is 5. The number of the okay. Here we can see that what is that 1000 and rest is 5 is there. Okay, 1000 address is R1 is taking 5. Okay, then R2 is taking 8. Correct. R1 2 plus then add move it's moving. Then here R1 plus R2, R1 plus R2, R1 plus R2, R1 plus R2, R1 plus R2 and store into the R2. 13, right? Then come here. Then decrease R1, branch of code. R1 minus R1 minus 1. R1 minus 1 is become 4. 4 then check. Branch on not 0. It's not a 0. Then loop will become again. It's not a 0. Branch on not 0. Branch on not 0 means it is not a 0. Then it's again go and go to R2 plus R1. R2 plus R2 plus R1 is storing into the R2. Then is 14 is 17. Then come to the next is decreasing by 1 is 3. Then come it's 3 not a 0. Again loop will come. Again because it's loop. Why? Because it's loop. Again its loop is going here. Then what happened? Then R plus 17 it's become storing into the plus. It's performing plus. It's become 20. 20 then come here. Then R1 minus 1. R1 is 3 minus 1 is 1 and storing inside the R1. Then it's become 2. Then come, this is the 0, not this is not a 0 branch on not a 0. So not a 0 branch is not on 0. So it's okay. Branch is not 0, 0. Then again loop will execute and R1 is 22. 22 then come again come here you can check minus 1 it's become now 1 now come again check 23 it's become then again r1 minus r is 0 now we will get the 0 then here check the condition is not 0 condition is 0 it's true and stop the value of r2 at the end of the program execution r2 is value is 23. Okay, loop is the branch on not zero. This is the important. Branch on not zero. This is the important. Correct. Next question is this is the gate PYQ question. Okay. So now instruction size also is given. Previously instruction size is in this question instruction size is not given, but right now the instruction size is given. Let's leave it remain. Okay. So let's try to solve it. Now consider R1, R2, R3 are the general purpose registers. R1 is instruction is this, operation is there. M1, R1 is memory address is 3000. Nothing is there, it's pointing to this. Okay, then R3, R3, R3 having something. Nothing, it's having assigned to R2, R2, R3, move R3, right? One instruction, two instructions, two, and here is one. Then R2 is one, right? Then R2 plus R1, R1 plus R2, R1 plus R2, R1 plus R2 stored into the R2, right? Correct. Then it's become 3, right? Coming to again, very confused. Here is 1, correct? R2. Okay. R2. Then coming to the next, then move R2, move to the R3. Move to R2, move to the R3. We make it any R3. Here, here. R2, move memory R3, move to R2, which is values there are 3, move here inside this. So R3 is 3, right? Correct. R3. Then R3. Let's see there's example. Okay. This question is there, but here you can see the assume that the content of the memory is rendered. ये दिया है ना पूरा solution इसका. Just I am trying to solving by using this, but not possible. Assume the content of the memory location 3000. That's why I'm shocking. But this is not there. Okay. Well, let's go solve that. So it's easy, but let's see. It's 2000. Start from the 2000. Okay. Here you can see 3000. Storing 10. The content of the register R3 is 2000. The content of the each memory is location from the 2000 to the 2010 is 100. The program is loaded from the memory location 1000. All the number are decimal. Access that access the memory is word accessible. Number of the memory reference for the accessing the data, executing the program completely. So memory is this 2000, 2000, 2000. First is storing 100. Then again it's storing 100, 100, 100, 100, repeat another 100. 100 is storing now. 2000 to 2030. Now first R1 is first 10. Then instruction you can see decreasing or increasing. It's storing R1 plus R2 हो रहा है और loop runs 10 times. Number of memory references 21. Consider the following program. Same question we have. Okay. So we completed. So these questions are too easy, not too difficult, but time, there is no right time to learn, but not a right time, but I need some more understanding on these questions. After that, I will repeat one more time. I want to see the explanation about these questions. What is internet? It's simple, guys. Here we go. Right, right. Instruction also in words, number of words. Okay, R1 is 10. First, you can see R1 is 10, right? Okay, now here you can see if you are able to see my screen, let me minimize. थोड़ा सा छोटा करता है उसका ना, then you can also see that. दिख रहा है क्या? Okay. The instruction size is 10, 10, 10, 10. I start with R1 as 10 and content R3 is to the content. Okay, R3 on the location. R2. R2 is 100, 110, 100. Okay. Next revision session, we will repeat this. Okay. So thank you guys, thank you. Bye. Good night, guys. So right now it's time to sit down. So I'm shutdowning all these things. So thank you guys. Thank you. We will meet another sessions. And one more thing I want to convey with you. Somewhere, sometime we will talk definitely. But currently I'm uploading, and also I have made it one Facebook uh, page for that videos. So there you can also follow. Okay. Thank you guys.